Hello, my dear viewers and my dear student. Welcome to my channel, Science and Vighyaan. Today, I am teaching bond energy and its calculation. As you can see, the topic is visible on the PPT. Fine. Before to it, please do subscribe my channel and don't forget to like and share the video. And I personally believe, अगर आपको समझ आ रहे हैं lecture, then it is your duty to subscribe my channel and tell others to subscribe the same. And guys, if you have any kind of doubt for the chemistry and for especially for the drug design, you can write in chat box. I would like to describe that in detail, and we can arrange a live session also for the same. Thank you so much. Now we will start the topic. Today our topic is bond energy and its calculation. Okay, do you have any idea what do you mean by bond energy? You know what is bond? Why two atoms they join together to make molecule? These are all about the curiosity in our mind. Or tell me why two hydrogen atom and one oxygen they join to make water. Why one carbon and two oxygen atom they join together to form carbon dioxide. This is all about the importance of bond, right? And today we will discuss the bond energy. Bond energy means the energy to required to break down the bond between two atoms. Okay, before to that, we should know why there is bond. For example, why we feel attached to other. This is all about the attraction between the two atoms or interaction between the two people. For example, if I like to stay in any society or in the company of any person, I have good bond with them. That is all about the bond, right? Okay. This is like whenever you see anything or whenever you see any phenomenon, you should know the reason why it's happened that. Fine. If you start finding the reasons or if curiosity will develop in your mind, my duty is over. Fine. Okay. Now we'll start the topic. Bond energy. The content are bond energy, calculation on the basis of different aspects, biochemical role, factors influencing bond energy, and last is a reference. And if you want to have reference from my side, if you want to have the PDF from my side, you can write in chat box. I would like to send the email also. Okay, bond energy, amount of energy required to break a bond. For example, this is a molecule. My two hands are molecule. I want to break the bond between these atoms. Sorry, if these are the two atoms, they make the molecule, and this one is a molecule. If I want to break this atom, what is amount of energy I have to require to break this bond? That is a bond energy, and it is expressed in kilojoule per mole. You can see when hydrogen and hydrogen they join together to make hydrogen molecule. After that, if I need to break them, I need to have plus 435.8 kilojoule per mole energy to break down the bond between these atoms. Fine. And we know what is delta H, that is enthalpy. Enthalpy is also all about the energy. Both are same. Enthalpy and energy both are same. Okay. This is this termed as enthalpy of atomization. Atomization means if I need to break two atoms within the molecule. Atomization. Okay, you can see this is the endothermic reaction. Endothermic means we need to give energy. Fine. That's why it expressed in the positive side. Okay, now we will discuss bond energy in the case of polyatomic molecule. Polyatomic, do you have any idea about polyatomic? We discuss polymer, polythene, polyatomic, polymolecule, polysaccharide. Now, what is all about this poly? Poly mean many. Okay, now, like in the first case, we discuss two atom only. This is a poly. Poly mean methyl, CH4. Firstly, we need to break H from methane. Methyl is CH3. The molecule is methane, that is CH4. We need to break one atom from this methane and it produces methyl plus hydrogen. And we need to require 427 kilojoule per mole energy. That is in the case of positive side. Next is again methyl. From the methyl, I need to break one more hydrogen. It produces methane, CH2 plus H positive. Again, I need to have 439 kilojoule per mole energy. Again, methane, CH2. It will break it down to form CH plus H, that is methylene. Again, I need to have energy, that is 452 kilojoule per mole. Again, methylene, it produces carbon and hydrogen. Fine, that is all about how we need to break the polyatomic molecule. Here, methane is polyatomic. Why it is polyatomic? You will see the carbon that is attached to the 4 different atoms. If I take, you can take my pies as carbon, and these are the different atoms. Firstly, I need to break the hydrogen, one more hydrogen, and last, all the hydrogen are broken down, and it produces carbon plus 4 hydrogen. The amount of energy required to break down this polyatomic. After that, we need to add all the enthalpy or the energy. And this is a calculation. After that, we have to calculate average bond energy for this molecule, that is 427 plus 439 plus 452 plus 347, that is divided by 4, because here the energy is broken down into 4 steps, and the average energy is found to be, that is 416 kilojoule per mole. Okay, next is bond energy in the case of heteronuclear diatomic molecule. Okay, now what do I mean by heteronuclear? Hetero mean different, nuclear mean if the nuclei is different. Example is HCl. Example is carbon dioxide. Example is water. Fine. Here, firstly, the bond energy that is given by, in the case of HCl, that is hydrochloric acid, when it's broken down, it produces hydrogen plus chlorine. So, energy enthalpy of formation for HCl is minus 92.2 kilojoule per mole. For hydrogen, that is 217.7 kilojoule per mole. And for the chlorine, it is 121.4 kilojoule per mole. So we can write their bond energy as, here we need to subtract the enthalpy of formation of the product and the reactant. It will produce, now what are the product? Product is hydrogen and chlorine. So product would be, we need to add the both product, that is 217.7 plus 121.4, that is equal to, after that we need to subtract minus 92.2. It means if we know minus and minus, they equal to the plus, so it produced 431.3 kilojoule per mole bond energy required to break down this heteronuclear diatomic molecule. And whenever when you watch this video, please do have your notebook in your hand and do practice along with me. Okay. Okay, we discuss bond energy, we discuss the homonuclear atomic molecule, heteronuclear atomic molecule, then polyatomic molecule. Okay, have you any idea why we discuss this? What is the application of this bond enthalpy data? What we can do with the help of this data? If we have their information, we can easily calculate their total enthalpy of reaction. For example, here we discuss the heteronuclear atomic molecule, that is H2 plus Br2, that is give rise to HBr. Here delta R H dash equal to bond energy of reactant minus bond energy of product, that produce 435 plus 192 minus 2 368. Here, this you can see here we need to minus 627. We need to subtract 736 from 627. That is give rise to minus 109 kilojoule per mole. That is the enthalpy of formation of the product of this compound. We can use the information of bond. You can see onto the right hand side, there is a table of average bond enthalpy. We can use this data for the calculation of bond enthalpy. Fine. If we have knowledge about the average bond energy of the reactant and the product, we can easily calculate their total enthalpy of reaction, or we can monitor the reaction very easily. Okay, spontaneous biochemical reaction. Spontaneous mean that is happened once without any energy. Example is when glucose and fructose, they are joined together to produce sucrose. That is a spontaneous biochemical reaction. And here enthalpy of reaction is plus 23 kilojoule per mole. Next, one more example. ATP, that is react with the water to produce ADP plus PI. We know what is ADP, that is adenosine triphosphate. When it joined with the water, it produces adenosine diphosphate and pyrophosphate. Pyrophosphate means when there is a one molecule of phosphate. Okay, again, after that, we can write glucose and fructose plus ADP, that is give rise to sucrose plus ADP, and here delta it is minus 8 kg per mole. Fine, we know that here we use energy. Here we use energy in the form of ATP and it yields ADP along with pyrophosphate. Next is what are the main factors that influence bond energy. First one is bond length. Bond length means, for example, if these are two atoms, fine, if I join them, what is the distance between their center of this atom? That is a bond length. Bond length of HF is hydrogen fluorine, that is 563, HCl is 366. And what is single bond? That we discuss, I have already discussed this with the help of stereochemistry also, with the stereo model also. What is a single bond, what is a double bond, what is a triple bond? If you have the recapitulation of the same, you can tell me. I will share the link with within the bio of this video. Fine, you can open that video and see the same. Fine, single bond, when there is a single bond between carbon-carbon, double bond and the triple bond. This is the primemost factor that is affecting the bond energy. Okay, this is all about the bond energy and the importance of the bond energy. And main factor is the bond length that influence the bond energy very effectively. Next is the MCQs. MCQs, this is a question to you. You have to find their answer. Fine. And in the next video, I would like to share their answer also. In the meantime, use a notebook and write in the option on the notebook. Fine, we will discuss the answer in the next video. Thank you so much. If you want, I can dictate the question. Okay, the formation of bond leads to dash of energy, liberation or absorption. Okay, I repeat, the formation of bond leads to dash of energy. First is liberation and the second is absorption. Next question. In case of polyatomic molecule, bond energy is given by average bond energy and the Gibbs free energy. Next is, I repeat the second question. In case of polyatomic molecule, bond energy is given by average bond energy or Gibbs free energy. Next question. Bond energy is dash proportional to bond length, directly or inversely. Last is, second last question. Bond energy is also known as enthalpy atomization, enthalpy of dissociation, or the both option A and B. I repeat, bond energy is also known as enthalpy atomization or atomization, enthalpy of dissociation, both A and B. Next is Positive value of bond energy indicates the reaction is endergonic, exergonic. I repeat, positive value of bond energy indicates that reaction is endergonic or exergonic. Please do write the answer on your notebook. In the next video, I would like to share their answer also. Thank you so much. Stay blessed, happy learning, and don't forget to like and share the video. And this is the reference for this presentation. You can open this book, P.D. Sharma book, textbook of chemistry class 11th, Jyoti publication, or any reference if you want to have, you can write in chat box. I would like to share the video, or I would like to share the content with you also. Thank you so much. Happy learning, stay blessed, and don't forget to like and share the video. Thank you, and please and don't forget to press this bell icon. Thank you so much. Happy learning, stay blessed. Bye bye.